All right, in this video, we are going to be talking about acid-base titrations, which is basically just a neutralization reaction. So you mix an acid and a base together um, until they become neutral, and we have a formula on the back of our reference table. So we'll need our reference tables, and we will need a calculator for this one. Now, before we get to our titrations, we have a bit of vocabulary to touch on. So we have mono, di, and triprotic acids. And this is very straightforward. We got 1, 2, 3. Protic means proton, so 1, 2, 3 H pluses. So our monoprotic acids are things like HCl that produce a single hydrogen ion when they ionize in water. Diprotic would be something like sulfuric acid, H2SO4, that when it ionizes, it produces 2 hydrogen ions, and triprotic would produce 3 hydrogen ions. All right, now our acid-base titrations. So it's a process of adding a measured volume of one of the acid or the base of known molarity to a base or an acid of unknown molarity until neutralization occurs. So for example, in lab, what we would normally do is we would normally have a certain acid. Let's say it was 0.1 molar. And we would add 15 milliliters of it to a flask. Then we would add an indicator. Often phenolphthalein is what we use for this. Then we would add the base until we got the indicator to change color. That would be how we would signal the end point. Now we would know the volume of the acid, we would know the molarity of the acid, we would know the volume of the base that we had been added, and then we could calculate the molarity of the base. So our titration formula is on the back of our reference tables. So here is our titration formula, and this is on our reference table. Now that might look very familiar. We did use that earlier in the year when we did dilution. So MA, molarity of the acid, VA, volume of the acid, NB is molarity of the base, and then VB is volume of the base. Now, there's kind of one little change on your reference table that you want to make. You want to multiply the acid side by the number of hydrogen ions present in the acid, and the base side by the number of hydroxide ions present in the base. So for example, if you had something like H2SO4, that's going to have twice as many hydrogen ions as a monoic acid, so therefore you need more base in order to neutralize it. So we just have to take that into account in the formula. All right, so get your calculators handy so that we can calculate these together. So we've got 50 milliliters of 0.250 molar KOH. Now it might be helpful to recognize the KOH is the base, and that's used to neutralize 20 milliliters of HCl. HCl is going to be our acid. You could always use table K and table L to help you with that. What is the concentration of the HCl? All right, so we'll start with our formula. So our formula is MAVA. Volume can be in either milliliters or liters as long as it matches on both sides of the equation. And don't forget the number of H ions present in the acid, number of OH ions present in the base. Often that's going to be 1 and 1, but sometimes it won't be. All right, so our acid is HCl. We have 1 H in it. We are looking for the concentration of our acid, so that's our unknown. And we had 20 milliliters of our acid. The molarity of the base would say KOH, is 0.250. Oops, I forgot my unit. The volume of the base used was 50 milliliters, and there's only 1 OH in KOH. So then we just plug that all into our calculator. So we do 0.25 times 50, divide that by 20, and we get 0.625 m, which is molarity. We need to check significant figures, three significant figures, so we are good with our answer. All right, next one. What volume of 1 molar sulfuric acid can be neutralized by 50 milliliters of 3 molar sodium hydroxide? So we're starting with the same formula. Again, to save space, I'm not going to rewrite it. All right, here's our acid. We do have 2 hydrogen ions present in our acid, so we do need to take that into account. The molarity of the acid is 1. And again, we are solving for an unknown from our acid, this time the volume of the acid. The molarity of the base is 3. The volume of the base is 50. And only 1 OH is present in my base. So then this one you probably don't even need your calculators for. Math is pretty easy. We'd have 150 divided by 2, so that would be 75 milliliters. Check significant figures, 2 significant figures, so we are good with our answer. So now you should try the problems in the titration worksheets that you have in the Google Classroom. Make sure that you are good with these types of calculations.